Hello everyone to a new video about algebraic linear equations by indicated products. What do I mean by that? Well, we have already seen algebraic linear equations by grouping or bracketing. We have already seen different other examples. These ones won't be that difficult because we're gonna combine what we saw with the distributive property of terms. So here we will have a constant, let's say a, and that a will be multiplying whatever is inside the parenthesis or the bracket or the brace, any sort of grouping. Now we must not only multiply by it but also apply the distributive property of this sign, which we have already covered. If you're a beginner, don't worry, this video is beginner friendly. So let's start with the first one. Would be the equation I'm writing right now on the board. That's simple enough. You just have to multiply to the first term and to the second in all of the cases, right? And also apply the distributive property of signs. You know how that works, do you? Negative times positive would be equal to negative. Negative times negative is equal to positive. Positive times positive is equal to positive. I guess that's everything you need to know. So 3 times 2x would be 6x. 3 times minus 8 would be minus 24. Minus 12 multiplied by 6 would be minus 72. Minus 12 multiplied by minus 4x would be 48x, positive sign, equal to 2 times 7x would be 14x, 2 times minus 3 would be minus 6, 9 times 2 would be 18, 9 times 4x would be plus 36x. Now what shall we do? We must have a reserved side of the equality for both the variables, which I would say will be the left side, and for the constants or the numbers that have the variable to the power of 0. For example, 24, 72, 6, all of those don't have a variable. Well, technically they do, but it's not seen. If you want to denote it like 6 times x to the power of 0, that's completely fine, but that's simply saying 6 multiplied by 1, and 6 times 1 is 6. Yeah, remember, when we pass a term to the other side, for example the 14x, we want to pass it to the other side, right? Since it's adding, it would pass to the other side to subtract opposite signs. So 6x plus 48x minus the 14x that came from the other side minus the 36x that also came from the other side. It passes to the other side to subtract. Would be equal to minus 6 plus 18. Those ones already remained in that right side. But what about the minus 24 and minus 72? They pass to the other side to add. And so it would be plus 24 plus 72. Alright, the operations in the left side would give us 4x. Do the operations on the right side, it would give us 108. So now what do? Since 4 is multiplying and we only need the value of x, 4 passes to the other side to divide, which means that x would be equal to 108 over 4. What about simplifying it? The half of 4 is 2, the half of 10 is 5, the half of 8 is 4, and now we can simplify it even more. The half of 2 is 1, and the half of 54 is 27, correct. And so x is equal to 27 over 1, the same as to saying 27. That is the correct answer for this first example. Now, what about the second? I will start writing the parent statement and then I will explain. We normally solve these kind of exercises starting with the distributive property, right? It won't be between a term and a parenthesis. Now it would be from a parenthesis to another parenthesis, like a set of parentheses. Once we have those two parentheses, we apply what is before, which would be the signs. And then these ones are the numbers that we will have to do the operations with. Let's start. 7x remains as 7x. Minus remains as minus. What happens therefore? Alright, open parenthesis. 5x times 4x would be 20x to the power of 2. 5x times minus 8 would be minus 40x. Perfect. Now let's continue with the 2. 2 times 4x would be plus 8x. 2 times minus 8 would be minus 16. Now let's pass to the other side of the equality. 51 remains as 51 minus, and then we apply the same distributive property. 4x times 5x would be 20x to the power of 2. 4x times 8 would be plus 32x. Let's continue with the 2. Minus 2 times 5x would be minus 10x. Minus 2 times 8 would be minus 16. So, remembering how signs acted with other signs, let's start. 7x minus 20x to the power of 2 plus 40x minus 8x plus 16. And what about the other side? So, minus 20x to the power of 2 minus 32x plus 10x plus 16. Perfect. Now, what happened? What can you see? Well, when you have a minus and you distribute that minus in a parenthesis, all of the signs inside the parenthesis will change. If you had a positive and you distribute that, well, it doesn't change. Let me tell you that. What happens now? Let's simplify the common terms. And this is something that you need to know. If you have two sides of the equality, there are gonna be some common terms. For example, a equal to a. Can you cancel it? You can. Why? If those terms are on opposite sides of the equality but have common sign, both of them are positive, you can indeed cancel them. But what if I had, let's say, minus a plus a equal to 0? Can you cancel them? Yes, you can. What can we conclude from that second example I gave? Opposite signs, but in the same side of the equality, they can also get cancelled. Applying that, minus 20x to the power of 2 and minus 20x to the power of 2, we can cancel both. What else can we cancel? Plus 16 and plus 16, right? What else? I believe that's it. Let's start writing it all again, but remember, one side for the variables, so x, and one side for the constants. 7x plus 40x minus 8x, and then we have to pass some variables from the other side. Minus 32x passes to the other side to become a plus 32x. And the positive 10x will pass to the other side to subtract. So minus 10x, and that is equal to 51. 51 stays like that. When you do the operations on one side of the equality, on the left side, what does that give you? It gives us 61x. And on the other side, well, 51. X is equal to 51 over 61, correct? Now, you may ask me, how do I check it? Or how do I verify if my answer is correct? Simple. If you want to verify it, simply put this value that x is equal to and slap it on every single variable that the parent statement has. So it would be 7 times 51 over 61 minus open parenthesis 5 times 51 over 61 and so on and so forth, and you will get that the first side of the equality would be equal to the second side of the equality. Of course, I'm not gonna do it since it takes a long time. It's just for you to practice. Now, the third example. As usual, I will write the parent statement and then we will solve the problem. Now, what shall we do? First, the parentheses, this ones, and this ones. After that, we distribute, whether it's a term, whether it's a sign. And then we do the operations. So, x times x in this first set of parentheses would be x to the power of 2 minus 2x plus x minus 2. Minus, we open parentheses and we start doing the other one. 4x times 3x would be 12x to the power of 2. 4x times 5 plus 20x minus 1 times 3x would be minus 3x. Minus 1 times 5 would be minus 5. And then write the other side of the equality. But remember, another parenthesis. X to the power of 2 plus 7x minus 3x minus 21. You know why, right? Because x times x, x to the power of 2, x times 7, 7x, minus 3 times x, minus 3x, minus 3 times 7, minus 21. Perfect. Now we start to solve. X to the power of 2 minus x minus 2, right? Since minus 2x plus x would be minus x. Remember, this sign distributes the rest of the parentheses. And since it is a negative, we change every single sign. Minus 12x to the power of 2 minus 20x plus 3x plus 5 minus 6 would be equal to 8x, and now we apply the distributive property of the terms. In this case, 11. 11 multiplies every single term inside the parentheses. Minus 11x to the power of 2 minus 77x plus 33x plus 231. Perfect. Now, we want to start diverging a little bit from the equation. Why did I say that? We want to first solve the x to the power of 2. In the left side, we will have x to the power of 2 minus 12 to the power of 2. In the right side, we will have minus 11x to the power of 2. And so, if 1 minus 12 is equal to minus 11x to the power of 2, then we can simply cancel. Cancel the minus 11x to the power of 2 in both sides. copy the rest of the equation because we're gonna pass to the next page, and I don't want you guys missing out, so let's continue. It would leave minus x minus 2 minus 20x plus 3x plus 5 minus 6 is equal to 8x minus 77x plus 33x plus 231. So as you can see, we got rid of the x to the power of 2, since we saw that common terms can get cancelled in both sides of the equality. After we have done that, let's start rearranging the terms. Minus x minus 20x plus 3x minus 8x, since the 8 from the other side passes to subtract, plus 77x, since it was subtracting, minus 33x, since it was adding, equal to 2, since it was subtracting, minus 5, since it was adding, plus 6, since it was subtracting, plus 231. That stays the same since it was remaining in the second side of the equality. Doing the whole operation, we can receive 18x is equal to 234. The 18 is multiplying, so it has to pass to the other side to divide, and so x will be equal to 234 over 18. Now, let's apply the halves. So half of 18 would be 9. Half of 234 will be around 117. Now what shall we do? We shall apply the third. Third of 9, 3. Third of 117 would be 39. And keep on applying the thirds. Third of 3 would be 1. Third of 3, 1. Third of 9, 3. And so x is equal to 13 over 1, which is equal to 13. Now that we have solved the most difficult example, I believe, of this video, let's continue with a significantly easier example, I would say, and it's our fourth example. So the parent statement will appear there on the board. What shall we do if we have indicated products on both sides? First, we apply the distributive property of terms like we saw before. First with the 4, then with the 5x, and in the right side of the equality, the same. 4 times 4 would be 16, and since 1 has the x, then 16x. 4 times minus 5 would be minus 20. Minus 5x times 4x would be minus 20x to the power of 2. Remember, x times x, x to the power of 2. Minus 5x times minus 5, 25x with a positive sign. And so we start with the right side of the equality. 10x times 7 is 70x. 10x times 2x would be minus 20x to the power of 2. And we keep on doing that. Same thing, but with the minus 3. Negative 3 times 7 would be minus 21. Negative 3 times minus 2x would be plus 6x. Perfect. What shall we cancel if we have common terms? Minus 20x to the power of 2 and minus 20x to the power of 2 in both sides of the equality. Remember, common signs, opposite sides of the equality. Opposite signs, same side of the equality. So now let's write it again, but this time with variables on one side and constants on the other. So 16x plus 25x minus 70x minus 6x. Why did I put this opposite and this opposite sign? Because here we have a positive, here we have a positive. If they swap sides, it would be an opposite sign, in this case negative. That is equal to minus 21 plus 20. Where did the 20 come from? Well, remember, we had a negative 20. Passes to the other side to have a positive sign. So let's do the operations in the left side of the equality. It would give us negative 35x. What would happen if we did the operations on the right side? It would give us negative 1. X is equal to negative 1 over negative 35. We can cancel the signs, right? Negative with negative, and x would be equal to 1 over 35. There we go. We're almost in the half of the video, so let's continue. Now we're going to the fifth example, which parent statement would be. Okay, so this is our parent statement. You see that we can apply distributive property to many things. Negative 3. Second, the positive. Third, the minus 8. And fourth, the negative. Let's start doing it. Minus 3 times 2x would be minus 6x. Minus 3 times 7 would be minus 21. Since it's positive and we distribute that, signs do not change. And so minus 5x plus 6. And then we distribute with the 8 and with the negative sign. Negative 8 times 1 would be minus 8. Minus 8 times minus 2x would be positive 16x. And then, remember, distribute the negative sign. It would change every single sign inside the parentheses. So, minus x plus 3. That is equal to 0. Now, what should we do? variables on one, constants on the other. Let's put the variables remaining on the left side. Minus 6x minus 5x plus 16x minus x, that would be equal to every single constant, this one, this one, this one, and this one. And since we changed the sides, we will change the signs. Perfect. So 21 minus 6 plus 8 minus 3. Now, what is the value in the left side? It will give us 4x. And what about the right side? It would give us 20. The 4 is multiplying, so it passes to the other side to divide. I guess you guys already know that. X would be equal to 20 over 4. We start applying the halves. Half of 4, 2, half of 20, 10, half of 2, 1, and half of 10, 5. X is equal to 5 over 1, or the same thing as the saying x is equal to 5. So look at that. The same value was the number of the example. Coincidence. What about the sixth example? We are almost finishing this bit. Don't worry, it is simple. I will write the parent statement and then you do it on your own to see how it goes. Remember, you must apply the distributive property and then apply common terms on both sides. Alright, since I have already written the whole parent statement, let's start doing it. This left side, it remains unchanged, right? You don't have to distribute anything else. So x to the power of 2 minus 5x plus 15 would be equal to, let's start distributing this by this times this, and this times this. X times x to the power of 2. X times minus 3 would be minus 3x. Minus 14 remains as minus 14. 5 times x would be 5x. 5 times minus 2 would be minus 10. Plus 3 times 13 would be 39. 3 times minus 2 would be minus 6. What can we cancel? We can cancel x to the power of 2 and x to the power of 2. Remember, they have common signs. But what if I wanted to cancel this and this? It can't be done, right? Since they have opposite signs. So now that we have simplified a little bit this equation, let's start putting variables on one side and constants on the other. Minus 5x plus 3x, because I changed the sign, minus 5x plus 6x. Remember, this one, and this one changes the signs. That is equal to minus 14 minus 10 plus 39. Those one remain the same. But what about the positive 15? It changes sides, and so it is negative 15. Good? Alright. What does the first side give us? The left side. Well, it gives us minus x, or minus 1x. That is equal to the right side. The right side apparently gives us 0, and so x is equal to 0. That would be the answer for the sixth question. Now what about the seventh? So, you guys do it, and then I do it. Seems fun? Alright. So, I will write the parent statement here. Alright, I guess that's a lot of things. First of all, remember, you must solve the 3 different set of parentheses. After that, you apply the distributive property with these terms outside the parentheses. And lastly, variables on one side, constants on the other, and then do the operations. So let's start. 5x times 3x would be 15x to the power of 2, plus 5x times 2 would be 10x, minus 6x times 3x would be minus 18x, 6 times 2 with a negative sign would be minus 12, minus 6, and then the other set of parentheses. 3x times x would be 3x to the power of 2, 3x times minus 1 would be minus 3x, and then 4x, since 4 times x, and lastly minus 4, since 4 times minus 1 would be minus 4. Minus 3, and then the next set of the parentheses, 9x times x would be 9x to the power of 2, minus 18x, plus x, minus 2. That would be equal to 0. What should we do? We can distribute. Now, with the terms, 3 times 15x to the power of 2, 45x to the power of 2, plus 30x minus 54x minus 36. That would be subtracting. 6 times 3x to the power of 2 would be 18x to the power of 2 plus 18x minus 24x plus 24. And then the next set of the parentheses, but now with the 3. So 3 times 9x to the power of 2 would be 27x to the power of 2 plus 54x minus 3x plus 6 is equal to 0. Alright, that all fit in the board. I'm sorry. So now, let's do the following. Let's put the x to the power of 2 in this side, then the x's on this side, and the constants on this side, and then equal to 0. Just to rearrange and to have it all better structured. 45x to the power of 2 minus 18x to the power of 2 minus 27x to the power of 2, followed by the x to the power of 1. But let's start simplifying to see what we can do. I have already seen one. Minus 54x and plus 54x. Those ones are inside the same side of the equality but have opposite signs, so we can cancel. Now let's continue. Plus 30x plus 18x minus 24x minus 3x minus 36 plus 24 plus 6, and that is equal to 0. Now what does this give us? 45 minus 18 minus 27. That gives us 0, right? So it would be 0x to the power of 2. And now let's rearrange in both sides of the equality. All of these must pass to the other side to do the opposite. And so we will have 30x plus 18x minus 24x minus 3x. All of that remained the same since we didn't change sides. That will be equal to 36 positive minus 24 minus 6. Alright, now what does the first side give us? It gives us 21x. What does the second side give us? It gives us 6. What would be the answer? X is equal to 6 over 21, right? We can apply the thirds. So third of 6, 2. Third of 21 would be 7. And so x is equal to 2 over 7. Alright, that was, I guess, the hardest example, but it wasn't that hard, was it? After doing this, I believe you can fairly simply do the next two. I would write the parent statement, you do it, and then I do it. Seems fine? Alright, let's start. So pause the video, do it on your own, and then come back. What shall we do here? Since there aren't any set of parentheses, we may as well just apply the distributive property. 2 times 3x would be 6x, plus 2 times 3 would be 6, minus 4 times 5x would be minus 20x, minus 4 times minus 3 would be plus 12. That is equal to x times x, x to the power of 2. X times minus 3 would be minus 3x. Minus x times x would be minus x to the power of 2. And lastly, minus x times 5 minus 5x. Perfect. Now can we simplify this even further? Yes, we can. Opposite signs on same side of the equality. X to the power of 2 and minus x to the power of 2. Now, what should we do? Variables on one side, constants on the other. So 6x minus 20x, the minus 3x and the minus 5x passes to the other side to do what? To start adding, right? So plus 3x plus 5x. And now let's pass to the second side of the equality. We have to move the 6 and the 12. Since they are both adding, they pass to the other side to subtract. And so it would be minus 6 minus 12. Perfect. So the left side, what value does it give us? It gives us minus 6x. And what about the right side? It gives us minus 18. And so x is equal to minus 18 over minus 6 when we cancel the signs, and also we apply the half. Half of 6, 3. Half of 18, 9. Third of 3, 1. Third of 9, 3. And so x would be equal to 3. You can verify it. But verify it how? Well, you put the 3 in every single one of the variables. So it would be 2 times 3 times 3 plus 3 minus 4 times 5 times 3 minus 3, and so on. What happens? That this number must be equal to the number you get on the right side. So the left side is equal to the right side, always. If it isn't, then, well, you got it wrong. Now, what about the ninth and last example for you to practice? I would write the parent statement, you do it yourself, and then you check if it is fine. If it isn't, then maybe you can follow this step by step. So there it is. Is it kind of hard? You just have to distribute the terms and then apply variables on one side, constants on the other. 184 minus 7 times 2x would be 14x. Minus 7 times 5 would be minus 35. Equal to 301, that stays the same. Plus 6 times x would be plus 6x. 6 times minus 1 would be minus 6, and then minus 6. Now we have to move and rearrange our terms. Minus 14x, then this 6x would pass to the other side to subtract. So minus 6x would be equal to 301 minus 6 minus 6. That remains the same, but these two pass to the other side with opposite signs. So minus 184 plus 35. The first side gives us minus 20x. The second side gives us 140. X is equal to 140 over minus 20. And what shall we do? Well, we apply the halves. Half of 2, 1, half of 0, well, 0. Half of 14, 7, half of 0 is 0. And then we apply the tenth. Yeah, so the tenth of 10 is 1, tenth of 70 is 7. So x would be equal to minus 7. Remember, the negative sign that the 20 had. That would be our result for the ninth and last example. How was it? Was it simple? Thank you all for watching. I hope this video has served a lot. And in any case, you can tell me in the comments to do more examples for you guys to practice. Thank you all, and I'll see you in the next one. So